hope you all are best and fine. Already class started, may not appear for you. Hope it is appear for you or not, it is visible for you or not. Students, yeah, wait for 1 minute, our friends may have to join in the class. And now already we are concluded our yesterday's whatever we are discussed about our current bill preparation. Here already we are discussed how to prepare a current bill. Okay, now compulsory you take here for what? For this purpose, for the our electrical current measurement purpose. Dear students, there is whatever we are discussed till now. There is that is only our part of this. That is electrical current. Whatever we discussed here. Now, in this part, the measurement of a current bill is very important. How the current bill is calculated and how the current bill is getting for us. Okay, clear or not, all of you? Now the power will be getting for us, that is only we are going to discuss now. Here there is a first example, it is given based on that whatever the readings are there, how many readings there is will get from that information. That is the first concept. The second concept is about here. The second concept is in case there is somewhat consumers they are given. For that consumer, how much the current bill may get for us. That is only we are discussing. Now, first thing is about what is the unit of a current. What is the unit of a current? Okay, clear or not, all of you? And as well as what is the units of a power? What is the units of voltage? Already we are discussed. What is the units of voltage? The volts are units for the voltage. Clear or not, all the students? Amperes are units for the current. Okay, now what is the units of power then? Already yesterday we are discussed. Power is equal to taken as work for a time. Power is equal to taken as work for time. It is measured in a what? It is measured in a watts. It is measured in a watts. Watt is equal to also written as 1 joule for 1 second. Means what? In 1 second, in case you perform 1 joule work, it's called 1 watt. Okay, but it is a very small unit for our current. That's why we are taking it is for an hour. Okay, clear or not, all of you? In case you take 1000 watts. Okay, clear or not, all of you? 1000 watts. It is called what? 1 kilowatt. It is called what? 1 kilowatt. That is only 1 kW. Okay, clear or not, all of you? In case this 1 kilowatt work is done for 1 hour, it is only treated as a 1 unit for measuring the power, whatever it will be given by government. Okay, now, yes, 1 kilowatt in case it will be used for one substance or used for this much of work is done for 1 hour, that is only called as 1 kilowatt hour. Okay, clear or not, all of you? That is only called as a 1 unit. It is treated as a 1 unit. Okay, clear or not, all of you? Suppose there is a 2 units of current, 2 units of power may utilized means what? 200 watt. Okay, clear or not all of you? 2000 watts are work in a 1 hour. It is called as 2000 okay now watts are work per hour. It is called as 2 units. Okay, clear or not all the students? Like this only are taken our current measurement. Otherwise power measurement and for a unit a charge is somewhat. Okay, that charge is only we are taken. Yes, multiplied with these units that will be for us current bill. Okay, clear or not all of you? Now go to for a second answer. Second the page number. Yes, here you take the page number 70. Page number 70 you have to take here. Yes, page number 70. Yes, in the page number 70 you have to take here. It is question number 2 in the page number 70. Yes, numerical problem is there. Okay, now what is that numerical problem? Suppose in a house there are 4 bulbs of 100 watts. How many is there? 4 bulbs of 100 watts. Okay, now clear or not all the students? And as well as there is another 6 bulbs are there of what? 60 watts. Clear or not all the students? And now there is about more 6 bulbs are there of 60 watts. Okay, clear or not all of you? Now there is about that electricity used for what? 30 days. And what is the rate for 1 unit here? The rate for 1 unit is 2 rupees 80 pies. 2 rupees 80 pies rate they are taking. Clear or not all the students? 2 rupees 80 pies rate they are taking. And what is the yes, what is the current bill for that? What is the current bill for that? Okay, clear or not all of you? What is the current bill for that? And now there is whatever we are taking here. Yes, data it will be provided. How much total watts are made? Yes, works for our bulbs purpose. Here, there is the first thing is about 4 bulbs. 4 into 100 watts are consumed for that. That's why it is a 400 watts. And as well as 6 bulbs are there with the 60 watts. That is 360 watts. And another one is there is about 40 watts. Next one is about 40 watts are there. 6 bulbs are there, each carries about 40 watts. That's why it is a 240 watts. Total how many watts are required to run these bulbs? Working of this all the how many bulbs? 4, 6, 6. There is a 16 bulbs are there. The 16 bulbs are works at a time. Okay, now there is a how much voltage, how much watts are required for us? How much watts of work may work for it here? There it is about 1000. Clear or not all of you? 1000 watts are works. For the running of that all the bulbs, this much of yes, power we required. Yes, but how much time they were running here? Yeah, they given what? Everything is at 2 hours. Everything is a work for what? 2 hours. Now, the total how many watts are required? 2 into 1000 watts. That is equal to become what? 2000 watts here. Okay, clear or not all of you? 2000 watts are okay works here. Now it is automatically what is become now? 2 kilowatt hour. Okay, clear or not all of you? 2 kilowatt hour. Okay, now that kilowatt hour means what? 1 unit of power may required. 2 units of per day, 2 units of power may consumed here. How many days? 30 days. Then how many units? 60 units of power may used for the bulbs in the 30 days. Okay, clear or not all of you? 60 units of power may used for the 30 days. For a unit, how much here? 2 rupees 80 pies. So now the current bill is become what? 60 into 2.80. Okay, clear or not all the students? Now automatically the current bill is become what? 168 rupees. Okay, clear or not all of you? How much it here? For a 60 units multiply with the 2 rupees 80 pies, it is become 168 rupees. Like that only current bill will get. Yes, it is for when there is given equal time. There is every bulb is work for 2 hours. But it is not like it is going on every time. Everyone is about same time. No. Yesterday we have taken one example. Okay, na? It will be works for a 4 hours. Another one is a work for a 3 hours. Another one work for a 6 hours. At that time, individually you have to calculate what is the wattage per hour. What is wattage per hour. Okay, clear or not all of you? I hope clear all the students. If you have any doubt, please ask me. Okay, clear or not all the students? Now, in case the problem is not like that they are given. The problem is given for us in this mode. Okay, clear or not all the students? Once again, I am taken one more problem here for you. Yes. In our home, we have taken 3 consumers. One is a TV. Okay, clear or not all the students? Another one, there is a 4 bulbs. Okay, clear or not all of you? One TV, 4 bulbs, 3 fans. Okay, clear or not all of you? The TV works for, there is 200 watts. And one bulb, each bulb is a work for 100 watts. Fans are work for 300 watts. Clear or not all of you? One fan is a work for 300 watts. One bulb is a work for 100 watts. TV is a work for 200 watts. It will be work for a 4 hours. For a day it is about 4 hours. Per a day it is a work for 6 hours. Bulb is a works 6 hours and the fan is a works 3 hours. Clear or not all the students? I hope you got it. One TV is there. The TV is required to work 200 watts and it is a work for 4 hours. The bulb is there. The bulb is a work for 100 watts only, but it is a work for a day 6 hours. And there is one fan is there. The fan is a work for 300 watts and it will be made work for 3 hours. Okay, now tell me, how many watts are per day? It is a required work all these things. Okay, one TV. That's why how to calculate here? Yes, 1 into 200 watts. How many hours? 4 hours. Okay, clear or not all of you? 4 hours it is a works. And now the next one is 4 bulbs are there. Okay, every bulb is required 100 watts. And how many hours? 6 hours. Here 3 fans are there. 300 watts are required. How many hours are works? 3 hours it is. Now it is 800 800 watts are consumed here, and here 6 hours. There it is a 400, that's why it is a 2400 watts. And here it is a what? 3 into 3 into the 3 hours and 3 consumers are there. Now there is, it is become what? 3 into 3 900, it is a 2700 watts. Totally how many watts for this particular purpose? There is how many watts are there? This much of watt here. Now automatically it is a become what? Here it is a 007 plus 4 11 and it is a 9 19 it here. Now it is a become 5900 watts per hours it will be works. Okay, totally per a day how many 900 watts are here? 5900 watts. It is written as in the form of a watt hours here. Here it is written in the form of a kilowatt hour, means by 1000 when you take it here it will be 8 kilowatt hour. 5.9 kilowatt hours works. Based on this one only you calculate the how much current will get for us. Okay, got it or not? This is only about the different hours they are given at that time, how much watts are may consume. Okay, for that particular hours that will be get for us. Got it or not, all the students? In this way only you calculate our current bill. Yes, it's a very important question for you. Yes, and now here given about one scientist, that is only my that is only what name of the scientist is Mitchell Faraday. Sorry, Michael Faraday. You know very well all the students, there is about Michael Faraday is one of the greatest scientists. Yes, by using the magnetism, by using the magnetic properties, he produced the current also. Okay, clear or not all of you? Yes, all the students, one thing, magnetism is nothing but what, Nana? Arrangement of a particles in a order. You already studied in your 6th class, playing with the magnet. On that lesson you are already studied, you take somewhat iron fillings. Okay, you take somewhat iron fillings. When you take iron fillings and on the paper when you pour that iron fillings, all iron fillings, and you change the location of that particular iron fillings by using there is a whatever the magnet you are taken below the paper. Okay, clear or not all of you? Yes, how they are coming, in case you pour it in the randomly, they are coming in the orderness. That is only called magnetism. Because of the magnetism, the particles are moved from one place to another place or not? Yeah. There is a what? How it is possible? Yeah, there is inside the electrons are also arranged in some particular order. Yes, clear or not all the students? Here there is, when we apply the magnetism, particles are arranged in some particular order. When you are used electricity, the particles are moved from one place to the another place. There is a what he concluded that the magnetism is not different from the electricity. Where the electricity is there, there the magnetism is there. Where the magnetism is there, there the electricity is there. That conclusion is taken and he proposed one law, that is only electromagnetic laws. Electromagnetic laws. By using that electromagnetic laws, he invented and he prepared one generator, electrical generator. Means what? In that is only called what? Dynamos and electrical generator may he consider. Okay, when we are changing the position of the particles, only he invented one of the very efficient and as well as very important devices for our electric current, that is only generator, electrical generator. Yes, how the electricity is generated? Yeah, the particles are moves very fastly. Okay, in case they are used for this magnet, okay now, yes, they are arranged in a particular order also, and it is easily to change the position of the particle by using the, yes, this magnet, and based on that principle only he prepared electrical generator. Once you observe, if possible, anywhere the electrical generators are there, what is going on? There is a one particle is rotated every time. Because of that, there is electricity is generated. Okay, clear or not, all of you? Yes. Yeah, that is only we are taken for as electromagnetic wave purpose. That about electrical generator working, electrical motor working, dynamo working, you have in your 10th class. Okay, now you wait for up to that time. Thank you, students. This is only the conclusion of our electric current lesson. If you have any doubt, please ask me. All the students, if you have any doubt, please ask me. Yeah, you have any doubt? Please write in your chat box if you have any doubt. No doubts are there till now in our lesson, electrical current? Yeah, all the students, and you know very well all from SA1 examinations are may started from here, May is going to starting from 11th onwards till to this date. There is a whatever the syllabus we are. Yes, till to this date, till to this syllabus, whatever we completed. Okay, now first to 7th lessons are may coming in your examination. Yes, our 6th lesson may not have in this examination. No, the Mitchell Faraday is not invented electricity. There is a electricity, not a particularly there is a no scientist is invented. But there is a provided somewhat efficient class. The first scientist may it is that first they get the first scientist is a given law based on Coulomb's. Coulomb's is one of the first scientists is a given the laws based on charges. Okay, now yes, there is a different of a number of series of experiment is performed by the scientist. Okay, the first they invented electron, then next invented proton. Okay, now then after they taken electrostatic current, then after they taken what electrical current. Okay, now electrostatic current is a different from electrical current. Like the number of series of experiments are going on. For the first generation, okay, now first electric generator are introduced by the Michael Faraday. Okay. Yeah. Now in this our lesson there is a somewhat keywords are there. Okay, what we are discussed in this lesson, simply we are what is the dry cell and what is the how there is a dry cell is a working and what the parts are there in a dry cell. That is a very important concept we are discussing. And how to prepare our own cell, that is also we are discussing. And then next we are discussing one more thing. Okay, that is only the connection, whatever the components are there in electric circuits. Okay, now mainly the battery, bulbs and sources, keys, switches, these are yes components in our electric circuit. When we are arranged in a particular order, that is only become the electric circuit. Okay, compulsory the electric circuit is a contain three parts. One is electrical source, another one is a connector, another one is a consumer. These are only the three parts we are considered. Clear or not, all the students? I hope you got it this information. And now there is a one more thing. It will be what is there? Yeah, there is how to connect these all the consumers. There is we connected the consumers in a which way? In a two ways especially. One is a parallel connection, another one is a series connection. Already we have discussed which one is called a parallel connection, which one is called a series connection. Which one is called a parallel connection? Common point, and the negative terminals, all the negative terminals are connected at another common point. It is only called what actually? It is only called as It is only called as what? Parallel connection. When we connected, there is a all the terminals, identical terminals are at a common point. It is called a parallel. Or opposite terminal is one is connected to the another one. Means what? Positive terminal is connected to the negative terminal. Negative terminal is connected to the positive terminal. It is called as series connection. Yes, what is going on due to the series connection? For the bulb's brightness, how it is varied already we are discussed it, we performed that experiments also. Okay, clear or not all the students? And then after we are discussed it, there is a very important point, that is only yes, what is the components we are used in that. Yes, and that is only heating effects are how they come from electric current. By using the heating effect, what the instrument we are used. Okay, what the instrument we are used? Electrical cookers and as well as iron boxes and as well as electrical bulbs. These all are yes works based on the heating effect of a current only. Then next, how there is a works based on heating effect? Yeah, when the electricity enter into one particular substances, it is not ready to flow through it. It is opposes first. Because of that opposing, that whatever the substance it will be contain electricity, that is heated. That heating is only we utilized for the bulb glow purpose and electrical cooker purpose, for iron box purpose. That property of opposing the electricity flow is only called resistance. Okay, clear or not all this? That is only we are discussed already about the heating effect of electrical current. And then next we already we are discussed about the tube lights and as well as the CFLS also. Okay, tube lights and CFLS are works based on the yes, when electricity passes through the gases, how they are glows, how they are actually the ionization is going on. About the ionization and everything will get in our higher classes. Okay, clear or not all of you? But there is no filament in containing the bulbs and tube lights and CFLS. You know very well what is the CFLS and what is the tube light and how they works. And after that, there is we already discussed about the fuse. What is the fuse? What is the MCBs? What is the fuse? Fuse is one of the thin wire, thin electrical conductor wire which is not allow the excess current through circuit. When the excess current through the circuit will become, it will be heated and melted, and the circuit is become opened. Because of the circuit open, there is a current is not passes into the main circuit. And because of that, there is a whatever the excess amount, whatever the heating effects, unwanted heating effects may coming in our circuit, that will be yes not allowed. Okay, yes, when there is a fuse we are using, fuse is become open, automatically the current is not enter into our circuit, and whatever the bad effects are coming because of electrical current may not, it will be allow that fuse. Okay, that is the fuse use. And MCBs. MCBs are fuse nothing but every time there is a melted, the wire is a melted, as we want to again reconstruct our electrical circuit, we replace that wire with the new wire. For overcoming of this problem, we are introducing one more consumer, one more electrical devices, that is only called MCB. MCB is nothing but miniature circuit breaker. Okay, now yes, every time we need not to change that whatever the device we are used as MCB. Just there is simply it will be automatically works or manually works. It is not allow the excess amount of electricity. Otherwise, in case a heating effects are occur anywhere, that will be also controlled by this MCB. And the last thing is electrical meter. What is electrical meter? Yeah, actually you know very well the current is in our home only. Yes, there is a power being comes from power station. Okay, now there is a power is produced somewhere. The produced power may changes its position from where? From powerhouses to our home in a various transformers. Total current is entered into our home from which device? Yeah, that device is only called electrical meter. That electrical meter is only sended the current through the electrical meter is sended the current actually to our what are all the consumer in our home. Got it or not? I hope you got it. And that is a convert the current from the direct to the alternate. What is the direct current, what is the alternate current, we are going to discuss in our higher classes. But it is also measure how much power is utilized in your home as in the form of electricity. Okay, clear or not all of you? Yes, that is how to measure and how to calculate. We already discussed yesterday and today also. Yes, electrical power measured in a watts. That watt is taken for 1000, it is called a kilowatt. In case it is taken per hour, it is called a 1 kilowatt hour. That 1 kilowatt hour is only called 1 unit. In case it is more than hours, it is hours. You calculate it, you will get the number of kilowatt hours. I hope you got it. This is only the information contained in our electrical current lesson. Yes, based on once you read the throughout lesson and write the keywords and the question answers. Tomorrow we will go with the discussion of our question answers. Thank you, students. And in our examination, 8th lesson also may come for you. 8th lesson also may come for you. Okay, clear or not all the students? Till we have the 3 days of time. Okay, for our examination, there is a 8th lesson also we are taken into our examination. Okay, clear or not all the students? I hope you got it. There is a whatever our 8th lesson, that is a very important and a small lesson is there. In case it is not completed before the examination, okay, I will provide for you, yes, in the form of a videos, in the form of a recording videos. Okay, clear or not? Thank you, students. Bye. Take care.